When wiring pole lights, adhering to proper electrical codes and safety standards is crucial. For the first question about wiring requirements, yes, 3 sets of hot and neutral circuit wires with a common ground are required. Each pole light needs its own neutral wire to ensure proper grounding and circuit isolation. Sharing a neutral across multiple circuits can lead to imbalances and potentially dangerous situations, especially with lighting loads. Now addressing the second question about disconnect requirements, a 3-pole disconnect at each pole light is not strictly required if the installation meets certain conditions. However, several factors must be considered. Firstly, accessibility is paramount. Any disconnect means must be readily accessible and easily operable from the ground level. This ensures that maintenance personnel can safely de-energize the light fixture without needing specialized equipment or climbing the pole. Secondly, grounding. Each pole light should ideally have its own separate grounding electrode system. This provides a direct path to ground for fault currents, minimizing the risk of electrical shock. A grounding electrode system typically involves a ground rod or other approved grounding conductor installed near the pole. Thirdly, isolation. Each pole light must be capable of being completely isolated from all power sources. This can be achieved through the use of a disconnect switch or circuit breaker that interrupts all conductors supplying power to the light fixture. This isolation capability is essential for safe maintenance and troubleshooting. A recommended wiring method involves running a dedicated conduit from the building to each pole light. Within this conduit, each pole light should have its own 3-phase circuit consisting of 3 hot wires labeled HON, H2, and H3, a dedicated neutral wire labeled N, and a grounding conductor labeled P for protective earth. This configuration provides a robust and reliable power supply to each light fixture, while ensuring proper grounding and isolation. Additional notes to keep in mind include ensuring that the circuit breakers are appropriately rated for the load. Since each pole light is rated at 400 watts, the circuit breakers should be rated for at least 400 watts each, but selecting a higher amperage rated breaker would be safer due to voltage fluctuations. The appropriate breaker size depends on the voltage of the system. Remember to consult electrical codes for the correct sizing. The conduit should be sized adequately to accommodate the number and gauge of conductors being installed. Overcrowded conduits can lead to overheating and potential fire hazards. Calculations based on the National Electrical Code (ONIC) tables should be performed to determine the appropriate conduit size. And finally, all connections should be made in accordance with applicable electrical codes and standards. This includes using approved connectors, properly torquing connections, and ensuring that all wiring is properly insulated and protected. Now let's dive deeper into the technical aspects of these requirements. Firstly, regarding the necessity of separate neutral wires for each pole light, this stems from the fundamental principles of electrical circuit design. In a multi-wire branch circuit where multiple loads share a common neutral, unbalanced loads can cause excessive current flow in the neutral conductor. This is especially problematic in 3-phase systems where harmonic currents can accumulate in the neutral. By providing a dedicated neutral for each pole light, you ensure that the neutral current is limited to the current drawn by the specific light fixture. This prevents overloading of the neutral conductor and reduces the risk of overheating and neutral voltage rise. Now let's consider the disconnect requirements in more detail. While a 3-pole disconnect at each pole light is not always mandatory, it is often the preferred method for ensuring safe and reliable isolation. A 3-pole disconnect interrupts all 3 phases of the power supply, providing a complete electrical isolation of the light fixture. This is particularly important for maintenance personnel who may be working on a light fixture while it is energized. However, there are alternative methods for achieving isolation. One option is to use a lockable circuit breaker at the distribution panel that feeds the pole lights. By locking out the circuit breaker, you can prevent unauthorized re-energization of the circuit while maintenance is being performed. Another option is to install a fused disconnect switch near the pole light. This provides both overcurrent protection and means isolating the light fixture. When selecting a disconnect method, it is important to consider the specific requirements of the installation and the preferences of the maintenance personnel who will be working on the equipment. Now, let's delve into the importance of proper grounding. Grounding serves two primary purposes. Firstly, it provides a low-impedance path for fault currents to return to the source, allowing overcurrent protection devices, such as circuit breakers, to trip and to energize the circuit in the event of a ground fault. Secondly, it helps to stabilize the voltage on the electrical system and prevent the buildup of static electricity. Each pole light should have its own grounding electrode system. This typically involves driving a ground rod into the earth near the pole and connecting it to the metal structure of the pole and the grounding conductor in the wiring system. The grounding electrode system should be installed in accordance with the requirements of the National Electrical Code, or NEC, which specifies the minimum size and depth of the ground rod, as well as the methods for connecting it to the electrical system. Now let's discuss the recommended wiring method in more detail. Running a dedicated conduit from the building to each pole light provides several advantages. Firstly, it protects the conductors from physical damage and environmental factors. Secondly, it provides a neat and organized way to route the wiring. Thirdly, it allows for future expansion or modification of the electrical system. Within the conduit, each pole light should have its own three-phase circuit consisting of 3 hot wires, a neutral wire, and a grounding conductor. The hot wires should be sized appropriately for the load, taking into account the voltage drop and ampacity requirements of the circuit. The neutral wire should be sized no smaller than the hot wires, and the grounding conductor should be sized in accordance with the NEC tables. Now let's address some common mistakes to avoid when wiring pole lights. One common mistake is to undersize the conductors. This can lead to excessive voltage drop and overheating of the conductors. Another common mistake is to use improper connectors or make improper connections. This can lead to loose connections, which can cause arcing and overheating. Another mistake is to neglect the grounding requirements. Improper grounding can lead to electrical shock hazards and equipment damage. Another common mistake is to fail to comply with applicable electrical codes and standards. This can result in unsafe installations and potential legal liabilities. Now, let's discuss the importance of proper overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the wiring and equipment from damage caused by excessive current flow. The circuit breakers or fuses should be sized appropriately for the load and the ampacity of the conductors. The circuit breakers or fuses should also be selected based on the interrupting rating, which is the maximum amount of current that the device can safely interrupt. In the event of a short circuit or overload, the overcurrent protection device will trip and energize the circuit, preventing damage to the wiring and equipment. Now let's discuss the importance of proper voltage drop calculations. Voltage drop is a reduction in voltage that occurs along a conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to operate inefficiently or fail to operate altogether. Voltage drop can be minimized by using larger conductors or by reducing the length of the conductors. Voltage drop calculation should be performed to ensure that the voltage at the pole lights is within acceptable limits. The NEC provides guidelines for calculating voltage drop and recommends that the voltage drop should not exceed 3% for branch circuits and 5% for feeders. Now let's discuss the importance of proper coordination of overcurrent protection devices. Coordination of overcurrent protection devices means selecting and coordinating the ratings of the overcurrent protection devices so that the device closest to the fault will trip first, minimizing the extent of the outage. Proper coordination of overcurrent protection devices is essential for maintaining the reliability of the electrical system. Coordination studies should be performed to ensure that the overcurrent protection devices are properly coordinated. Now, let's discuss the importance of regular maintenance. Regular maintenance of pole lights is essential for ensuring their safe and reliable operation. Maintenance activities should include inspecting the wiring and connections, testing the overcurrent protection devices, and cleaning the light fixtures. Any damaged or worn components should be replaced promptly. Maintenance records should be kept to track the maintenance activities and identify any potential problems. Now let's talk about safety precautions to take when working on pole lights. Firstly, always energize the circuit before working on any electrical equipment. Use a voltage tester to verify that the circuit is de-energized. Secondly, wear appropriate personal protective equipment, including safety glasses, gloves, and insulated shoes. Thirdly, never work alone. Always have someone nearby who can assist you in case of an emergency. Fourthly, be aware of your surroundings and watch out for hazards such as traffic, overhead power lines, and slippery surfaces. Fifthly, follow all applicable electrical codes and standards. Now, let's discuss some of the different types of pole lights that are available. Pole lights are available in a variety of styles and wattages. Some common types of pole lights include high-pressure sodium lights, metal halide lights, and LED lights. LED lights are becoming increasingly popular due to their energy efficiency and long lifespan. When selecting pole lights, it is important to consider the lighting requirements of the area, the energy efficiency of the lights, and the cost of the lights. Now let's talk about the energy efficiency of pole lights. Energy-efficient pole lights can save a significant amount of money on electricity bills. LED lights are typically much more energy efficient than high-pressure sodium lights or metal halide lights. When selecting pole lights, look for lights with a high lumen per watt rating. Now let's discuss the cost of pole lights. The cost of pole lights can vary depending on the style, wattage, and energy efficiency of the lights. LED lights are typically more expensive than high-pressure sodium lights or metal halide lights, but they can save money in the long run due to their energy efficiency and long lifespan. When selecting pole lights, consider the total cost of ownership, including the initial cost of the lights, the cost of electricity, and the cost of maintenance. Now let's talk about the environmental impact of pole lights. Pole lights can have a significant impact on the environment. Light pollution can disrupt the natural environment and harm wildlife. Energy-efficient pole lights can reduce the environmental impact of lighting. When selecting pole lights, consider the environmental impact of the lights and choose lights that are energy efficient and minimize light pollution. Now let's discuss the importance of proper disposal of pole lights. Pole lights contain hazardous materials such as mercury and lead. Proper disposal of pole lights is essential to protect the environment and human health. Pole lights should be disposed of in accordance with applicable environmental regulations. Many municipalities offer recycling programs for pole lights. By following these guidelines, you can ensure safe and effective installation of pole lights. This includes proper wiring, grounding, isolation, and overcurrent protection, as well as regular maintenance and adherence to applicable electrical codes and standards. Ultimately, safety should be the top priority in any electrical installation.